We live in a very fast-changing world. Compared to 20 years ago, the U.S. Patent Office now issues about 3 times as many patents every year. It's a rapidly changing world for technology. It's also a rapidly changing world for risk. Again, compared to 20 years ago, most of the risks that we dealt with were physical risks. Risks that were based in the principles of science and physics and chemistry, of electricity, of fire. Principles that were immutable and could therefore be dealt with unchanging and reliable solutions. Today, however, we deal with very different challenges. For example, in the world of cybersecurity, we deal with human risks that change as fast as the solutions can change. And that means it's important for us in the world of safety to figure out how to develop resilience in our solutions so that we can keep up with the changes that are happening in our society.
We live in a changing world, one filled with amazing opportunities, but also evolving risks and new threats to safety. Storms and water may make the headlines, but rising temperatures bring their own additional set of challenges. The overall risk of heat-related illness or death has climbed steadily since 1980, and nearly a third of the world now lives in places that have deadly temperatures at least 20 days a year. Cyber attacks, a vulnerability that has grown with our transition to an interconnected information society, are also on the top of people's minds. Though it is hard to quantify the risk, industry experts generally view economic infrastructure, financial services, as the most vulnerable to cyber attacks. But utilities failure poses a potentially more dangerous threat to public safety, and hardly a month goes by without new evidence that infrastructure systems around the world have been compromised. As we move from hardware to software as a key driver of performance in industry, in manufacturing, in our infrastructure, on our streets, and in our skies, we open up new vulnerabilities in our critical systems. Our interconnectedness as people, societies, and economies has the potential to amplify the impact of these vulnerabilities. On a similar note, our material flows are interconnected. Our supply chains extend across the globe, with components being created in varying conditions for worker safety, product quality, and integrity assurance. Our waste disposal economy also reaches around the world. Our rivers carry more than 8 million tons of plastic into the ocean every year. The point is that the impact of the total exposure is far greater than what could be predicted by examining any one component on its own. Resilience engineering has 3 main characteristics. First, it focuses on the performance that the system is supposed to deliver, not the system itself. It focuses on learning from successes, not just diagnosing failure. It encourages building capacity to learn, adapt, and evolve. It recognizes that the distribution of risk and the probability of various events and other stresses is changing. Resilience engineering is part of a larger orientation toward amplifying successes, encouraging innovation, and revaluing collaboration across sectors and geographies to tackle the changing context that we live in. The traditional risk management approach focuses on identifying and diagnosing failures. Resilience engineering also shines the spotlight on the successes that emerge even in the midst of collapse. This more even attention to the consequences of decisions made under uncertainty creates additional room for taking considered chances, the kind that just might have a transformative impact. Resilience engineering's emphasis on learning turns our attention to improving our capacity to monitor, anticipate, and respond to change, to communicate and integrate what we know more effectively. It values intelligence as a critical part of any product, process, or system. It revalues science and engineering as an important basis for decisions.
So, why UL to lead this effort in resilience engineering? To me, it really goes back to the history of our company 124 years ago, leading the effort in society to safety engineering. Well, resilience engineering is the next step. It's more than just looking backwards at failure. It's looking forward to success and to risk management and to using the knowledge that we all have to make products both safe and resilient. It's also because UL has a real capability in convening experts like yourselves to come together to solve problems. And that leads to the third point. Why you? Because you are the experts, the people who have the knowledge, the know-how, the involvement every day with students at universities, with public officials who are helping to make policy, with companies who are making products, and the community at large that's writing standards and deciding what's important. Together, we can make a great success out of resilience engineering, just as we have for more than a century made the world a safer place.